Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about one of the core component which is used in embedded system design, that is 8086 microprocessor. So if you look at the embedded system, it contains various hardware components. First, we are defining the requirement behavior. Open the door or close the door. Open the airbag. That functionality is defined in the form of instructions. These instructions are executed by using system core components, and these instructions are stored in the memory devices. And while doing the operations, we are getting the current data, current room temperature, current pressure, or any unknown person entered in front of the vehicle. That current data is getting from the input devices by using sensors or switches, whatever may be input devices. And the output will be monitored or control the output devices, like open the airbag, lock the wheel. That will be happen by using output devices like actuators. And do the special operations by using additional hardware circuits like analog to digital converter or digital to analog converter or real-time clock, watchdog timers, counters, like so on. And share the information among all these peripherals by using communication interfaces. So, if you want to design particular embedded system, we require all these peripherals. So one of the peripheral is system core. System core is used to executing the instructions. That may be either microprocessors, that core components may be either microcontrollers, either field programmable gate array, or application specific integrated circuits, or digital signal processors, or system on chips. Any one of the core, one or few components we can use in our design. So specifically in this session, we are going to discuss about microprocessor. One of the core component is microprocessor. So what is microprocessor? What it will do? Why we need to use this microprocessor? Microprocessor is a single silicon chip that represents central processing unit. This microprocessor performs the arithmetic operations, logical operations, and control operations. So examples, Intel 8086 microprocessor. We will discuss of these features and architecture. So this is the 8086 microprocessor IC. So it is available in 40p dual line package. So first we discuss about the features of Intel 8086 microprocessor. So microprocessor processing the instructions means executing the instructions. So first, 8086 is a 16-bit microprocessor. 16-bit means at a time it will process the 16-bit information. Suppose ECE. So each letter contains some ASCII number. Suppose capital A 65. That ASCII number. So B, C, D, E. So for capital E, the ASCII number is 69. So what is the binary number for 69? So 1000 100 101 initially 0. So this is the 8-bit information for capital E. In the same manner, each information contains some binary number. So this binary number will be accessed at a time 16-bit information. This is 8-bit information, 0 to 7 bits. At the same time, EC 67 for the corresponding binary information, like that. At a time, this 8086 microprocessor process the 16-bit information. At a time, in the sense, in one clock cycle. Next, it has 16-bit arithmetic and logical unit. Means, it will add the two 16-bit numbers, or it will do the arithmetic operations on two 16-bit data. Suppose we can take two 16-bit numbers 1, 2 plus 3, 4. Or, sorry, 1, 2, 3, 4, 5, 6, 7, 8. In the decimal point of view. Corresponding binary number are 1 means 0001, 2 means 0010, 3 means 0011, 4 means 0100, 5 means 0101, 6 means so this is A, this is B, sum of A plus B. Next single clock cycle, it will add these two 16-bit numbers, like that. Similarly, either arithmetic operations, addition, subtraction, multiplication and division. At the same time, logical operations like logical and logical or NOT operations or XOR operations, like that. Based on the requirement, in the single clock cycle, it will perform the arithmetic and logical operations on 16-bit data. Next, it contains 16-bit data bus. Like, if you look at the pin diagram of 8086 microprocessor, it contains AD0 to AD15 pins, A16 to A19 pins. Here A indicating address pins, D indicating data pins. In one clock cycle, it fetches the data like D0 to D15, totally 16-bit data. In another clock cycle, it will fetch the 20-bit address like A0 to A19, totally 20-bit data, address information. 20-bit address. Okay. So what is the advantage? Instead of multiple clock cycle, in a single clock cycle itself, we can fetch the 16-bit data, and 20-bit address location in the single clock cycle. So, number of clock cycles reducing means execution time reduces. Execution time reducing means speed increases. Like that, we can improve the speed when comparing with 8085 or previous processing elements. Since it accesses 20-bit address bus, it can generate 2 power 20 memory locations. Bit means either 0 or 1. 20 bits means minimum value 20 zeros, maximum value is 20 ones. So total range is 2 power 20 memory addresses we can generate. Means 2 power 20 means 1 megabyte memory. Means this 8086 microprocessor can interface with 1 megabyte memory card. Up to maximum memory capacity is 1 megabyte. Okay. So when comparing with previous versions, it is somewhat better. Previously, we can access only 64 kilobytes. So we can increase accessing from 64 kilobytes to 1 megabyte. Like that. Next, 8086 microprocessor uses memory segmentation. Means it can generate 2 power 20 memory locations, that is 1 megabyte memory. That 1 megabyte memory is divided into segments. So 0th segment, first segment, and so on. F. Total 16 segments. So each segment size is 64 kilobytes. Like address range is 4 zeros to 4 zeros to 4 Fs. Okay. So what is the advantage? Instead of combining or overlapping the information, suppose I want to access the code, I can directly access the code segment only, not data segment, or not stack segment, not extra segment. So whatever the operation I am doing, corresponding information is available in particular segment, so I can access the information from corresponding segment only, instead of the overlapping of other segments. That is the advantage. Avoid the overlapping of the information. Next, it uses two-stage pipelining concept. So what is the need of pipelining? Pipelining means parallelly doing the multiple operations. Example, fetch and execute. So fetch and execute. In the first clock cycle, I can fetch the first instruction. In the second clock cycle, I can execute the first instruction, at the same time fetch the second instruction. In the third clock cycle, I can execute the second instruction, fetch the third instruction. In the fourth clock cycle, I can execute the third instruction, fetch the fourth instruction. Suppose if you are doing the same operation individually, so in the first clock cycle, fetch, decode. Fetch the first instruction, second clock cycle, execute the first instruction. Third clock cycle, fetch the second instruction. Fourth clock cycle, execute the second instruction. Like that, as the based on number of instructions. Suppose I am doing addition operation. Move AX, 1. Move BX, 2. Add AX, BX, INT 03. This contains 4 instructions. If you want to do these operations without pipelining, we require 4 into 2, 8 clock cycles. With the two-stage pipelining, it requires 5 clock cycles only. So what happens here by using pipelining? The number of clock cycles required that will be reducing here using pipelining when comparing with without pipelining technique. So with pipeline, we can take only 5 clock cycles. Without pipelining, we can take 8 clock cycles. So 8 clock cycles means that execution time is more when comparing with 5 clock cycles. So we are reducing the execution time. Reducing the execution time means improving the speed. Like that, we can improve the speed by using pipelining technique. Next, it contains 6 bytes of instruction queue. Means it contains program counter, it prefetch the instructions. While prefetching, that information is stored in the instruction queue. Prefetch. Okay. Instead of fetching the instructions while doing the operations, we can prefetch. So what is the advantage? We can no need to waiting for fetching operation. That is readily available in the instruction queue. Up to that size is 6 bytes. That up to 6 bytes. So we can avoid the waiting time for doing the fetching operation. Next, this Intel 8086 microprocessor is available in different packages. One of the packages is 40-pin dual inline package. So it contains 40 pins, that is in 2 lines. So 1 to 20, 21 to 40. Total 40 pins. Next, it is available in 3 different clock rates. Clock frequency indicating the speed of the operation. So F equal to 1 by T. As the clock frequency increases, that execution time reduces. So time reducing means speed increases. So as the clock frequency increases, speed increases. So this 8086 microprocessor is available in 3 different clock rates. One is 5 MHz clock, 10 MHz clock, and 8 MHz clock. Okay, 3 different versions. Next, 8086 microprocessor is operated in 2 modes, that is minimum mode and maximum mode. Whenever the microprocessor do the operations by 8086 itself, at that time that doesn't require to interface with external processor gigabits. At that time, that 8086 is operated in the minimum mode. So 8086 does not support floating point operations. At that time, 8086 needs to be interfacing with 8087. So at that time, that is operated in the maximum mode. Okay, like that, based on the requirement, if the operations done by the 8086 means that is operated in minimum mode. If it is not possible to operate by the 8086, at that time it needs to be interfacing with external processing elements like 8087 and do the operations by the 8087. At that time, that 8086 is operated in the maximum, the same minimum. 8086 is operated in the minimum mode when only one processor is to be used in the microprocessor system. The maximum mode is used when more than one processor are used in the system. So these are the features of 8086 microprocessor. Next, 8086 microprocessor architecture. See this architecture once. So if you look at this architecture, this is divided into 2 parts. First one is bus interface unit. Another one is execution unit. Bus interface unit is defined for fetching the instructions from the memory devices or input devices. Execution unit is designed for executing the instructions. You will check it on how it is doing. So if you want to know clearly about architecture, first you need to know the register organization of 8086 microprocessor. If you look at the register organization of 8086 microprocessor, it contains 14 16-bit registers. Those may be accumulator, base register, counter, destination register. Next, code segment, data segment, stack segment, extra segment registers. Next, instruction pointer, base pointer or stack pointer or source index, destination index and flag register. These are the 14 16-bit registers available in the 8086 microprocessor. First, I want to find out the address from which I can fetch the instruction. How I can get that information is that instruction address. So, if you look at the memory organization, it contains segment address and offset address. Suppose 0th segment, offset address 02, 0th segment, offset address is FF. This is the range. Or you can take any one of the segment. So first I wanted to find out the segment address of the instruction that is available in the code segment register. And the particular segment, 0th segment, first segment, 0, 1 and so on. In that segment, in particular memory location, the instruction is available. That offset address of the instruction is available in the instruction pointer. Then we can calculate 20-bit physical address. So segment address into 10 plus offset address, that is equal to the 20-bit physical address. That is 20-bit physical address. So here we can do the calculations, addition. So segment address into 10 plus offset address. So we are getting 20-bit physical address. Then go to the 20-bit address. From that we can fetch the instruction. But fetched instruction is stored in the instruction queue. Instruction queue. So it can fetch up to 6 bytes of memory location. Okay. After getting this instruction, based on that will be decoded. After decoding the instruction based on the type of operation, if it is arithmetic and logical operation, that information is passing to the ALU unit. If it is control operation, that goes to the control unit. Okay. Suppose I want to do the addition operation. I want to add two numbers. At that time, that where that two numbers are located, that instruction is find out the 20-bit address, go to that memory location and fetch that instruction. Add AX, BX. That instruction is coming to this arithmetic and logical unit. While doing this operation, it requires AX value, that is AHAL and BHBL. That is getting from this accumulator register and BX register. Then do the operation by using this arithmetic and logical unit, and the result is stored in the destination register. Okay, suppose move AX comma 1, move BX comma 2, add AX comma BX, INT 0. So in the accumulator I am storing 1. In the base register I am storing 2. And this what is the meaning is that value 1 is moving into the accumulator. Value 2 is moving into the BX register. Next, add the content of BX register with the content in the accumulator, and the result is stored in the accumulator. Then break the operation. So, after completion of operation, based on the result we are getting here, that flags will be affected. In the result, if the carry is generated, carry flag 1. Auxiliary carry generated means the auxiliary flag is 1. If the result is negative, sign flag will be 1. By default, all flags are 0. Whenever the functionality will be reflected, that value is 1. Okay. If the result is more than the defined size, then overflow occurs. Okay. While doing the operations, if interrupts are enabled means interrupt flag is 1. Like that, we can do the arithmetic operations and logical operations and control operations in the 8086 microprocessor that is used in our embedded system design to execute the instructions. So for this topic, the reference textbook is IARE. Okay, the textbook name is Advanced Microprocessors and Peripherals by the Tata McGraw-Hill 2006 edition. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.